Hi, I'm Mary, and this is another magical math moment. In this video, we're going to be looking at phase shifts of sine and cosine functions, and it can get a little bit intense. Now, it starts off kind of simple, right? We've got y is equal to sine of a quantity x minus pi. And if you are a good algebra student, you probably remember that this is going to be a horizontal shift. And since it's a negative inside here, it's the opposite of what you think. So it's not going to be going left, it's going to be going right pi units. All right, so we're going to shift over pi units to the right. So let's see what that looks like for our graph. Normally, when we're plotting this, we're going out to pi over 2, to pi, to 3 pi over 2, to 2 pi. But now this is a little bit strange, right? Because I'm going to be starting my graph right pi units. So instead of starting at 0, I'm going to start over here at pi. So that's my first point, my second point, my third. I need a fourth and a fifth. But I also need to figure out these values. So if I'm increasing by a half pi each time, this would be 2.5 pi or 5 pi over 2. If I add another half to this, 6 pi over 2 or 3 pi. So let's see how this looks. Sine curves start at the midline. So I'm going to start right here on the axis. I'm going to go up to 1, back down to the midline, to the minimum, back to the midline. And there's my sine curve. That was gorgeous. Can I graph like that every time? Wow, sometimes I impress even myself. All right, so that one wasn't horrible. Is it gonna get worse? Of course it is. Here's a cosine curve, and you may be looking at this and thinking, there's a couple of things going on. The first being, there is going to be an adjustment to the period. Remember, that's a b value. And the period is always 2 pi over b. So in this case, it's 2 pi over 2, which is pi. So our normal cosine graph is going to be squished in halfway of what it normally is. To figure out where to start this thing, take whatever is in your parentheses and set it to where cosine normally starts, 0. Okay, so if I solve this, I'm adding a pi on both sides, and then I'm going to divide by 2. So that means that my start point is going to be at pi over 2. My end point will be my start plus the period. So for this one, I'm starting at pi over 2, and I'm adding that period of pi. And we'll say x equals, because that's nice and pretty. So I've got pi over 2 plus 2 pi over 2, because you need a common denominator when you're dealing with the fractions. So we've got 3 pi over 2 as our endpoint. And I always like to take a minute and make sure this makes sense. So 1.5 minus a half is indeed 1 pi, which is what the goal is here. Okay, now we should be ready to sketch this beautiful thing. So 1, -1. Well, that's not even at all. We'll put 1 up there, -1. Okay, this thing is going to be starting at pi over 2. So again, we're shifting right. So we've got pi over 2 here. And then we're going to be ending at 3 pi over 2. So normally pi is here, and then 3 pi over 2 is here. All right, now remember, we need 5 points. I have the start, I have the end, I have the middle. So I have to think about what's halfway between a half and 1.5. And hopefully you know that's pi. Okay. The other thing I need to do is figure out what these values are. So a way to kind of, not cheat with this, but to kind of figure out the easiest way to do it, these numbers aren't bad, because I know halfway between a half and 1 is 3/4, right? I can also kind of think of this like, what if I figured out half of a half this way? It'd be pi over 4, 2 pi over 4, here's 3 pi over 4. So can I fit that? 3 pi over 4? Yes, I can. 4 pi over 4, 5 pi over 4. There we go. All right, so this thing starts at pi over 2. Cosine starts high, then it goes to the midline, then it goes to the min, back to the midline, back up to the max. You're going to try to curve it as best you can. There we are. I don't know, but I think my graphs are kind of fire in this video. The last couple haven't been so hot, but I'm on it right now. So there we have our phase shift. We're going over pi units to the right. And then we also have that period that shrinks the graph in. There you go. What about something ridiculous like this? Okay, this is a little bit wild. So this has the b value out front for you. So we know b is 1/2 this time. So the period is 2 pi over 1/2, which is 2 pi times 2, because when we divide by a fraction, we're multiplying by its reciprocal. So this period is 4 pi. So we're going from 2 pi out to 4 pi. We also have a shift going on. Because it's positive in here, you probably know we're going to be going over to the left this time by pi over 3. Now these numbers are a little gross, so get ready, all right? Again, we're going to take what's here and we're going to go ahead and set that to 0, where sine usually starts, right? So I've got 1/2 times the quantity x plus pi over 3 equals 0. I'm going to go ahead and distribute the half in. You could divide it on both sides, but I think this is kind of fun, so I just want to show you this. All right, I need to bring that over, so now I have 1/2 x is negative pi over 6. I distributed this in because I want to show you what happens here, because I think that's valuable. We've got negative pi over 6 multiplied by 2 over 1, which is going to give us negative, this is going to reduce, 2 pi over 3, which you probably could have surmised from this. So here's your start point. I just want to show you the algorithm just so you have an idea. And then we've got to find our end point by using our start point plus the period of 4 pi. So we need a common denominator. I've got negative pi over 3 plus 12 pi over 3. 12 divided by 3 is 4. Negative 1 and positive 12 is 11. So this is going to end at 11 pi over 3. Ew. So we want to make sure when we're setting up our graph, a lot of students get messed up by the y-axis. I don't want you to get messed up by the y-axis, okay? So this thing is going to go far, and then we're going to do something like this. So that's why we know we're going up 1 and down negative 1. Okay, we're going to start at negative pi over 3. So I'm just going to kind of go over here somewhere. Negative pi over 3. All right. This is a distance of pi over 3. So we got to kind of think about where our points are before we start doing tick marks and all that. Because the temptation is just to put one like on the other side here. But I'm not entirely sure if that's going to work, because if I go right over here, I'm at positive pi over 3. That distance is 2 pi over 3. And that's no good because the period's 4. That means 1/4 of that is 1 pi. And this is only 2 pi over 3. So we're going to go over like a little bit more. So that's 1, 2, 3, 4, oh Lord, 5. All right, a little uneven, but you get the idea. Okay, so negative pi over 3 is here, 11 pi over 3 is over here, and we need to figure out these other tick marks. So I'm looking at the numerators. I've got negative 1 here, I've got 11 here. If I add that, I get 10, and if I divide it in 2, I get the midpoint. So I end up at 5 pi over 3. That's this middle one right here, 5 pi over 3. Okay, next I'm going to look at this second point on our graph. So I'm going to look at negative 1 plus 5. and then divide it by 2 because that's the midpoint. That's what I'm looking for. Notice it's not the midpoint from 0 to 5 pi over 3, okay? It's from the start point to the middle point, to the third point. We want the second point. So we've got 4 over 2, which is 2. That means this is 2 pi over 3. All right, 2 pi over 3. And then finally, I want this point, which is halfway between 5 pi and 11 pi over 3. So if I add that up, 5 plus 11 divided by 2, 16 over 2 is 8 pi over 3. I don't know why I'm writing that, just 8. All right, so let's see. We're over here at 8 pi over 3. Now before you graph it, take a minute and make sure this math makes some sense, okay? Let's see, we're starting at -1/3, and then I'm going to +2/3. I know that's a distance of 3 pi over 3, which is 1. From 2 to 5 is another 3, or 3 pi over 3, which is 1 pi. From 5 to 8 is a distance of 3 pi over 3, which is a 1 pi. 8 pi over 3 to 11 pi over 3 is a distance of 3 pi over 3, which is 1 pi. 1, 2, 3, 4 pi, which is the period. So we did it right. I'm so glad when the math works. All right, let's sketch this thing. This is a sine graph, so it starts at the midline. So here we are. Then we go up, back to the midline, down, back to the midline. So here, oh man, I had to say something about how nice my graphs were. I got cocky, and now it looks like junk. Well, I recovered nicely. This first part, you can ignore that, but you get the general idea. So you can see this thing is very stretched out. It's also shifted over a little bit. So I told you it was gonna be a little weird. Hopefully it makes sense. And I'll be doing another video where we do phase shifts, vertical shifts, amplitudes, reflections, all kinds of crazy stuff. But for now, that's it. I hope that this has been helpful. Please, if you enjoyed the video, like it, share it to your friends, subscribe so you can see some other magical math moments. That's it for now. I'll see you soon. Bye.